Tells me that it's recording. Okay. All right. So today, on the schedule, I had put that we would continue the generics and we would go ahead and do the wild cards thing. Actually, what I would prefer to do is to go ahead and discuss the the assignment that I posted this morning. Hopefully, you have all seen that. You've gotten a chance to at least take a brief look at it. So it's not going to be modifying the code that you've already been doing. That will be your final assignment. Your final. There will be one more, a fourth assignment coming before the end of the semester, and the plan is that that last assignment will kind of expand one final time on the store project. Hopefully, you guys are excited about both doing the assignment, but also I imagine many of you are probably also excited about being done with this whole store project, right? So anyway, let me go ahead and I'm going to pull up the assignment description. Let's see. 1 second, let me get this going right here. Okay. Let me pull up the PDF here of the assignment description. Okay, that's something else. This is it right here. Okay. All right, so this is going to be assignment 3. All right, so you will have, like I said, one more. So you do have to submit a Java file, but now instead of being assignment 3 student number.java, it's going to be assignment 3 tests. So what's going to happen is we're going to write a set of test cases for what you created for assignment 2, which should incorporate everything from 101 that we finished last year, but then also incorporates the assignment 1 and assignment 2 expansions that we did so far in 102. All right. Then the other thing that you're going to need is you're going to need to submit an assignment 3 UML underscore your student number. And then there's no extension given here because the format is up to you. You're going to have a lot of options as to how you can submit this, right? But you do need to submit both of these things, a Java test case file and then also a UML document, okay? So let's get right on into it. So basically what I want to see is how well you understand the basic design and testing phases of what we've talked about. So we talked about testing, we talked a little bit about design over the past couple of semesters, right? And so, like I said, a lot of first-year programmers, myself included, when we went to write our code, when we went to write our solutions for what our professor asked for, we just kind of sat down and started typing, right? And I'm assuming that for many of you, you probably figured out that that wasn't always the best way to do things, right? So what I want you to understand is some aspect of the design phase, which is where the UML document comes in, right? And then the testing is the post code. Once you've written your code, what happens after that, right? Okay, so the first part of this, the test cases, let's I kind of did, actually I did the files in the reverse order of how I described them down here, didn't I? Well, okay. So let's talk about the first part first, the UML part. Okay, so that's going to be, you're going to need 2 sets of diagrams. All right. The class diagram that should show all the classes that you developed according to the project description, according to the assignment 2 description, which is, I have this up over here, right? And then also the relationships that exist. And this is both types of relationships. This is both the aggregation composition relationships, that would be the has a type relationships, but it's also going to be the is a relationships, the generalization the extends, right? The extends relationships, okay? So you need to be able to show how both of those are done in a UML class diagram. You'll also need to show all the attributes for the different classes and make sure you put the attributes in the correct place, okay? Don't have attributes that don't belong in some classes, right? Don't put them in other places, okay? All right, and then something that we talked about was this whole activity diagram. Now we also mentioned it, I mentioned it very first week or second week of 101 when I talked about flowcharts, okay? So the way that would look, now this is the way we kind of drew it in 101. If you remember back to that first week, second week of 101 last year, this was the kind of the symbols that I used in an example for a flowchart. Okay, an activity diagram basically is a flowchart. Okay, now there's a lot of different ways that we can draw an activity diagram, and I'll show you some of those in just a moment. But what I want to show you here, one of the things I wanted to introduce you to was this diagrams.net. And I don't remember if we talked about this in this class before, or if I've only talked about it in other classes that I've taught. But diagrams.net, or also sometimes draw.io. So both websites will go to the same place. So this one, diagrams.net, will get you here. You can click on start. If you go to draw.io, right, you'll come to a slightly different looking thing, but notice it says draw.io is now diagrams.net. So you can just go to diagrams.net. One of the nice things about this is that it connects directly with your Google Drive if you choose to let it do that. Okay, and you can create a new diagram. Right, if we come over here and we click start, it'll come up with the same thing, right? So this is the same thing. Okay, so you can create a new diagram, right? You can create a flowchart. You could create a UML. This is one type of activity diagram, and this is another type of activity diagram. Okay, and I'm going to show you both of these because basically what I did for these three tabs up here was I just clicked on this and said create. Okay, so it just created a template. It used a template for an example diagram of each of these types. Okay, so if we look at the basic one, this is the one I would expect you have the most understanding of. Is you have a task. This would be kind of like a line of code. You have an arrow showing the flow, showing how the process flows, how the task flows. Okay, this diamond shaped thing is a decision node. It can be either an if statement or a loop. Remember, a loop is just a decision node that comes back and checks the decision again and again and again until the decision is false. Okay, so this would be an if statement. If we were to do this in code, we take one path if it's yes, one path if it's no, one path if it's true, one path if it's false. So this would be an if else statement. Okay, an if statement with no else would just go and connect up somewhere else down here. So we have a couple of back-to-back if statements. And so what we do if those things are true or false, and then we end up with a final end of the activity, end of the flow down here. Okay, so you would need to be able to create one of these for a method. So the start node, the start up here, would be whatever the first step in your method is. Okay, then you would have whatever your conditions are, if there are conditions, follows through a set of tasks. Okay, a set of steps. Okay, it's a visual way. Basically, what an activity flow diagram or a flow chart or an activity diagram, these are all terms that we use for the same basic thing. Basically, what it is it's a visual way for us to understand how a task flows. Okay, it's so that both programmers like us who can read code and understand it, right, both programmers and non-programmers alike can look at a task and understand what's going on. Okay, so is there, let's see, is there a question? Good question, or I'm going to get to that. Okay, so let's go back. Where was I? Right here. Okay. Actually, I was over here, wasn't I? Right. So that I'll go ahead and answer that now before we get too much more into the other types of activity diagrams that you can use. So when I say create an activity diagram for all methods that require one, okay, and that's what I was getting at with this whole require one. You don't need to create an activity diagram for a method that just we call it returns a value. So like a get method. So like if you had, I don't think I have it up right now, but so like if you had a method that was just the get price method, and all it does is it returns the price, you don't need an activity diagram for that method. Okay, that's not required. If there's a method that does something else, that does more than just sets a value, does more than just returns a value, then yes, you need an activity diagram for that. So that would include methods like the set price method that could throw an exception. So it does do more than just sets the value. There are other methods that they just set the value. I think like for example the set calories method, if I remember correctly. Let's see. I'd have to pull up assignment 1 actually at this point to go back and look at some of those more simple methods. Yeah, so like get total due here. If you have stored that, if the total due is stored as a single variable in your class and it just returns the value of that variable, you don't need an activity diagram for that. However, if your get total due, if you stored the total due, if you didn't store it as a single amount, but instead kept track of all the individual prices and accounts and all that, and you kept track of that in like an array list or something like that, and your get total due method had to loop through that array list to get a total, then you do need an activity diagram for that. So anything that's more complex than a single line of code, you need an activity diagram for. Okay, I hope that clears up that question. All right, so let's go back to here. So again, this is the simple one. So basically, if you had some type of method that just if we take the price in, right, is price in greater than 0? If so, then we can delete this, this. We can move this up into here. Right. Set price. And notice that one thing I want you to notice. This does not have to be Java code. This this information here, these steps, they don't have to be Java code specifically. Right. It can be more of a pseudocode style, right? But it does need to be able to be useful for both programmers and non-programmers alike to be able to understand what's going on. Okay, and this would be what? This would be error or exception, something like that. Okay. Now, if a programmer can look at this and say, I know how to write that in whatever code language they have of choice, Java, Python, whatever, right? If they can look at this and know how to immediately write that as a Java method or other programming language method or function, great. That's what we're looking for, okay? So basically, again, you don't have to write Java code specifically in here, okay? So let's move on to a couple of different versions of this. So this is the simplest. This is the one that probably most of you have seen before, you're familiar with. If you choose those UML options. So the UML, the activity or activity 2 diagram here. Okay, I'm going to show you what those look like. Okay, because that's a little bit different. One difference is they'll start with a start node. Okay, so you'll have this node that it is specifically a start node. Notice that there's a difference between the start node and the end node. There's a little bit of a difference. The start node is just a black dot. The end node is that same black dot, but has kind of this red circle around it. Okay. Steps, same, right? It's this block, although it's a little bit, it's not rounded on the corners, but you know, that's neither here nor there. So this would be like your steps. This would be like what would represent a line of code, right? And then again, we have this diamond-shaped decision node, right? And then this is like a split, so it's basically for concurrent processing. I wouldn't expect you would need this because not a lot of our methods and our stuff we're doing at this level is going to result in a lot of parallel processing things going on, right? But it's basically it's a very similar looking thing, right? You have this decision node that you should be able to tell this could become a loop, right? This becomes a loop. We come back over here, we do this again, we have a decision, we keep going. Okay, so this would be represented as a loop. Okay, this is for, like I said, a multi-threaded system, this whole parallel processing thing. So it's more complex, and if you understand this stuff, if it's clear to you what a lot of these symbols mean, feel free to use them. If this other flowchart example makes a lot more sense to you, as it does me, just feel free to use this. Okay, just do what you understand. Okay, and then finally, we have an activity diagram, a second version of that. Again, with the parallel processing, right? Actions look like this, so this would become our kind of lines of code. It can create objects and do other actions, right? And so it's just different different shapes, but mean the same thing. Okay, so basically, I wanted you to be aware that there's different versions of this whole activity diagram flowchart concept of how we draw these things. Okay. Again, though, you would end up with, let's see if we did this. You'd still have this whole condition decision node thing, right? You can start something, you can end something, you can tell it to go here if there's a something like that, right? And you can connect them. And the nice thing about a tool like this is I can move this around and it stays connected, so I don't have to redraw it every time. Okay. Again, one thing I want to stress is you are not required to use this tool. Okay, if you want to draw these things by hand and scan them in as an image file or something like that, or you want to or scan them in as a PDF or take a picture of it with your phone, as long as it's understandable, that's what's important. Okay, so if you want to draw these by hand, do it. That's fine. If you want to use one of these tools, that's fine. Also, PowerPoint. PowerPoint has the ability to be able to draw things like this. Okay, draw things in these shapes. All right. So, and I think Google Slides would too then. So if you want to use any of those tools, you want to do them by hand, it's entirely up to you. There's no requirement. The requirement is that it is understandable. Okay, so we need to be able to look at your activity diagram, and we need to be able to understand the flow of your method. Okay, and the nice thing is for you is that if you've submitted assignment 2, which I'm assuming all of you have since the deadline was Monday, all right, then you have all this done. you have all the methods written. You just need to take that Java code and change it into a visual symbol, right? And so the nice thing is that you've actually already done the work. You've already done the coding. So now you just need to go and create this activity diagram. Okay. Absolutely, in the ideal situation, if you were working for a company and making money doing this, what you would do actually is you would create these two first. You would create the class diagram, you would create the activity diagrams first, and then you would write the Java code from those. So we're kind of doing this a little bit in reverse, but I do want you to understand how to take the code and be able to make it into a visual representation that that our users, our customers can understand. Okay. Now let's move on. So assuming there are no questions from that, you can write to the group. I'll get a little notification down here if you write a question. But thank you, Or, for that question, by the way. And so if there's nothing else on the UML stuff, we'll get into the test cases. Okay. All right. So as far as test cases are concerned, so this is kind of the other side, if you will, the other immediate side of development. So most programmers, we like to think about the writing of the code as being the work we have to do, and we don't like thinking about design, and we definitely don't like thinking about testing, because the reason that we don't like thinking about testing is, as I've said before, testing cannot prove that a system works. The goal of testing is to find places where it doesn't. Okay, you don't test bridges across rivers. You don't test them by putting the lightest possible car on them, do you? You want to test using things that should break it if the thing has a problem, right? And so a lot of times software developers, if we're not actively involved in testing, we don't like the testers. We don't like the people whose job is to find problems in our code. But it's important. It's very important that we find those problems if they're there. Okay. And so what I want you to do is I want you to act like a tester for your code. Okay. I want you to create a set of test cases for the project you created in assignment 2. Code coverage must be followed. I mentioned that when I talked about testing a couple weeks ago. What that means is that every method, every line of code must be executed at least once in your test case, okay, in your set of test cases. So if we go back to here, right? So if we look at a method, a very simple method like this, okay, it means that in order to have code coverage, this line must be executed at least once, right? We must get a price in, and this if statement must be executed at least once. Okay. Now, so you might say, oh, well, that's one test case. And you're right, that as long as you have a test case that executes this path, right, this path, then you've got code coverage for those 2 lines. But we must also make sure that both of these lines get executed as well. Okay. And so what that means is we need a test case that follows this path. We also need a test case that follows this path. So that means for a method like this, for a method with a single if statement, we would need 2 test cases. Okay. That's the only requirement that I put on this, was that you had to have code coverage and that all methods must be tested. So which really, if you have code coverage, then all methods are tested anyway. You cannot have code coverage if there's a method that's not tested, because the lines inside of that method would not be tested. And so it's a little bit of a redundant requirement here, but nonetheless, it's still there. And so one of the things I'm not requiring for this assignment is that you do what we called edge or partition testing. If you go back and look at, there's a video on that I did. I encourage you to do it just because it's good practice, but it is not required. You do not have to do edge or partition testing, okay? But you do have to have at least one test case that would follow this path and at least one test case that follows this path, okay? So there's another term in testing that we call path coverage that has to do with this for whenever our methods get way more complex than a simple single if statement, right? But we're not going to get into path coverage here in this lecture. All right. So points will be deducted for any tests that fail when run on your assignment 2 submission. What that means is that basically your assignment 2, I'm going to consider removing this requirement only because I did not make this assignment and assignment 2 concurrent like I did last year when I did a similar thing. And by making them concurrent, I was trying to encourage you to do the test cases first. In this situation, okay, I'm going to think about this one. I'm going to think about whether or not I'm going to keep this requirement in there. I do encourage you, though, that if you write a test case and it fails, that you look into why did it fail? Why, is it something wrong with assignment 2 that you wrote incorrectly that it failed that test case? Or was it possibly a problem with the test case itself? Okay. So, I do encourage you to at least look at that, but I'll think about this one. I'll make sure I'll let everybody know by the end of the day what I decide with that. Okay. All right. Reminder. Okay. Just like with previous programs, your program does not require a main method. Right? You do need to make it a set of test cases. So if we go back and we look at, I'll pull up JGrasp here. Let it come up. When we looked at testing, that was lecture 5. Yeah, so test, there we go. So remember that the way that we create a set of test cases, so, all right, is, we have to import some JUnit stuff. And we do have this whole before and after thing that may or may not be used, right? But remember, we need our test cases to be individual methods, void methods with the test compiler directive, right? And it needs to have an assert statement. If you want to be reminded of how to write test cases, because there was both this one and this one right here. Okay, a reminder about how to write test cases and how to use the assert statements and stuff like that. I encourage you to go back and review that lecture as well. All right. But this is what we're wanting, basically, is a class that is called assignment 3 test with your student number, and then is a set of test cases that we should be able to use on your assignment 2 to make sure that things get tested appropriately. Okay. So one Java file, that's the assignment 3 test. One other file that, it can have any number of possible extensions because it's basically the UML class and activity diagrams for us. Okay. And basically, like I said, so you're not expanding the store program. That will come later. We will expand it in a couple weeks, but you have basically about a week and a half. No, what is that? 11 days. So yeah, like a week and a half to be able to take your assignment 2, write a set of test cases, and the UML diagrams for it. Okay. So, are there any questions regarding this assignment? So if there's no questions regarding this assignment, then we will go ahead and call it a day, because there's not really enough time for me to get into anything new today anyway. And so we'll end here, and I'll say have a good weekend, and a reminder that you have a lab tomorrow, also online, like this lecture is. And if you have any questions, make sure you get those to us sooner rather than later. Okay? All right, well, have a good afternoon, and I'll see you guys next week.